Hi AP Stat students, this is 8.1. We're going to be talking about confidence intervals for this whole chapter. The way this chapter is laid out is the first section is all about confidence intervals in general. The second section is about confidence intervals for proportions. And the third section is about confidence intervals for means. So a confidence interval. We use confidence intervals to make an estimate about a population. We take a sample and use it to estimate the population parameter. We used x bar to estimate mu, these are our means, and p hat to estimate p, those are our proportions. Will the statistic match the parameter? Well, remember from that sampling variability and when we do our sampling distributions, no. Most of the time, our p hat could be above, below. Maybe it will match the parameter, but it's rare. But it should be close. So we use an interval and hope the interval captures the population's true measurement. So what we have is our point estimate. So our best guess as to what the true parameter is. So our estimate of the proportion is p hat, and the estimate of our mean is x bar. Then we have plus or minus our margin of error. And we'll talk margin of error right now. Think about a population with a mean of mu and a standard deviation of 12. You take a sample of 36 from the population. What would the sampling distribution look like? Well, so the sampling distribution would have our mu and our sigma of 2. So what boundaries is the middle 95% of the sample means? Well, remember we have that empirical rule where 2 standard deviations from the mean is 95% of the data. So here's one standard deviation, that's 2, and this is 4. So that's 2 standard deviations above and 2 standard deviations below. So we have mu plus or minus 2 standard deviations, so 2 times 2. Okay, so mu plus or minus 4. Okay, right, 4 above and 4 below, right, the above and below. Could we do the middle 90% of the data? Well, we could. We know it's going to be more than one standard deviation away, but it's going to change this 2. Okay, we haven't shown you how to do that yet, but you might be able to figure it out. I'm going to show you this a little bit more generally first. This is mu plus or minus 2 times that standard deviation of the sampling distribution. So sigma over square root of n. So the key characteristics, we have our point estimate p hat and x bar. We have our margin of error, which is going to be our critical value times our standard deviation of the sampling distribution. Then we have this level of confidence. So the level of confidence is what this was up here. The middle 95%, the middle 90%. It's the probability that we will capture the true parameter and then the interpretation. This is a Mad Lib. You see where there's the blanks? We're just going to fill in the blanks. We are blank percent confident. This is our confidence level. That the interval from blank to blank, so this is the low part of your interval, this is the high part of your interval, contains the true, and this is the parameter, of, and this is the context. Now right away, this seems kind of complicated. You're going to do so much practice with this, you'll be fine. A confidence level C, which gives the overall success rate of the method for calculating the confidence interval. That is, in C% of all possible samples, the method will yield an interval that captures the true parameter value. Okay, that's exactly what I said. So in a 95% confidence level, 95% of the time, the interval will capture the true parameter. So typical ones are 90%, 95%, 99%. The higher the confidence is larger margin of error. That makes sense. Like a bigger interval, a larger margin of error would create a bigger interval that is more likely to capture the mean or the proportion. So interpreting. So we have interpreting confidence level versus interpreting confidence interval. So that confidence level, remember, is we say that we are 95% confident is shorthand for 95% of all possible samples of a given size from this population will result in an interval that captures the unknown parameter. Okay, so we can add in the actual context and stuff. Their confidence interval is to interpret a C% confidence interval for an unknown parameter. We say we are C% confident that the interval from blank to blank captures the actual value of the, and then we say the parameter in context. Okay, we've already talked about that up here. In late 2009, the Pew Internet and American Life Project asked a random sample of 2,253 U.S. adults, do you ever use Twitter or another service to share updates about yourself or to see updates about others? Of the sample, 19% said yes. According to Pew, the resulting 95% confidence interval is 0.167 to 0.213. So we interpret the confidence level. 95% of all possible samples of size 2,253 will result in an interval that captures the true proportion of people that use Twitter to share updates. We are 95% confident that the interval from 0.167 to 0.213 captures the true proportion of people who share updates or see updates on Twitter. So when we do all of this, we need to start following this pattern. We need to state the procedure. So this is the confidence interval. We have the conditions, our three conditions. We need our random condition, that is a random sample or random selection or a random assignment. We need a normal sampling distribution. So remember those things from the last chapter. We have the NP and N1 minus P are both greater than or equal to 10. Or we have, for means, we have a normal population or we have n greater than or equal to 30, and we have that central limit theorem. We need independent samples, and then we do our calculation, and then we do our interpretation that we are blank % confident that the interval from low to high captures the true parameter in context. So the picture on the left shows a sampling distribution with an unknown mean. Below the distribution, there is a point with the margin of error accounted for on each side. How many of these intervals capture or include the true mean of the population, and what proportion is this? So we have 25 intervals, and 24 out of 25 capture the true mean.